Alright, so here are a few tips for you as you're doing these, right? Tip number 1, always, so you want to jot these down, write down the page. I was just checking if you're still awake. Always write, and I know a lot of you are doing this already, but just in case, right? Always write down the page. So what I mean by that, year 11, just coming back. Are you ready, guys? So always write down the page. So you should always have that equal sign going down the page like that, okay? The next thing is, there should always be a variable on one of the sides. Okay? Because some people like to do, for example, in this first step we do 25 take away 10. Some people like to write 25 take away 10 is equal to 15 as a part of the step. Just do that in your head mentally. Don't need to write that down anywhere. If you want to do it on the side, you can. Okay. But Luke, you had a South African way of doing this one. Can we hear it?
Wait, which one?
This one over here.
That's not the same question.
Isn't it?
It's the first one. That's a different one.
Oh, it's a different one. Okay, we'll do this one for us anyway, while we're here.
105x equals 25 minus 10.
Yep. Sure, and that's 15.
Yeah. And then put x equals 15 over 5.
Yep.
That equals 3.
X equals 3, perfect. Next one for me, go George. This one over here.
I do times 2 on both sides.
Yeah, multiply by 2 on both sides.
You get m minus 5 equals 12.
Perfect.
Then I plus 5 on both sides.
Easy.
M equals 17.
M equals 17, yeah. And by the way, guys, probably in an exam, you can get away with just writing these 2 steps here. If you're happy to do that, these steps you don't need to write down. If you can do those in your head, that's fine. Okay. Ethan, can you help me out with this one over here? What's the first thing you did? Yeah. Boys, just listening up. Luke, I know you're talking about it, but let's just listen to Ethan. Yeah. What did you get?
So minus the 4 off.
Yeah. So that becomes 17. Yep.
Then you divide times it by 3.
Yep.
And then it should be.
Multiply both sides by 3.
Yep.
And what did you get?
Should be y equals
51, was it? Perfect. Okay. So you can see how you can save a bit of time with these ones. Now, how do they make them tricky, I guess, is the question. These are a few examples of how they're different. To recognize why they're a bit more difficult first, though, what's actually different about these 2 examples here? What can you guys see? Yeah, good. First one is variables on both sides. George, what did you try for this one?
I did it a weird way at first where I don't know how I did it.
Yeah.
First, how I ended up doing it
Yeah.
was I plus 5 from both sides first.
Yep.
And then I minus 8 n from both sides.
So you add 5 to both sides. So that's going to go away. And what happens to this? That becomes 22. Perfect.
And then I minus 8 n from both sides.
So you take away the 8n from both sides. That works for me.
That's the one with the South African.
That's the South African way, is it?
That's the one with the South African.
Yeah, right. So you get 2n is equal to 22. Is that okay so far? Yeah.
Doesn't matter which way you do it. Like, can you take away the 8n first?
Yeah, good question. Doesn't matter which way you do it. So let's just do it on the slide over here. The short answer is it doesn't, right? Compared to these ones though, right, the order for these ones can matter, right? But for these ones over here, the order won't matter here because if you took away the 8n first, you'd get 2n minus 5 is equal to 17. And then if you added the 5 after that, you'd still get 2n is equal to 22, right? So either way, you're going to end up with n is equal to 11 when you divide both sides by 2 there. So it doesn't matter which way you do it, right? And the same for the next one. There's actually 2 ways you can do this one. Robbie, what did you do? Yeah, so Robbie expanded first. That's multiplying everything on the inside by the outside. So 2 times 7 is 14. 2 times 8x is 16x. And what did you do from there?
Minus the 4n.
Yep. So you subtract 14 from both sides.
And then keep the negatives cancelled out.
Yep.
0 times that.
Okay, I just want to stop here because this one's a bit weird. Tristan, when you looked at this one, What was your first thought when you saw this here? Yeah, like it looks a bit strange. Like, why is there just a 0 on one side? It's actually possible for the value of the polynomial to be 0. And if you put that in your calculator, that actually does equal to 0 there. Okay. Yeah, so just make sure you don't... That's why it's really important you get the order right. Because if you get the order wrong there, then you'll get a math error in your calculator and that won't work. But that actually does work when you put it in there. Right? But there's another way to do it. I don't know if anyone saw the other way to do it. It can be easier, but they don't do another one. Yeah, you're right. The other way you could do it, Samara said, you could divide both sides by 2, because this here is just multiplication, right? So if this is just multiplication, the opposite of that is dividing. So that gives me 7 minus 8x is equal to 7. And then you'll get a similar kind of thing. That's also going to be 0. And when you put these back into the original equation here, that actually does work, right? So, for example, 2 times 7 is just 14. The 8x is going to go away. Right? Okay, so this is the one that was giving people a little bit of trouble with this one here, right? Thoughts on this one? Willem, did you ever go at this one?
What one?
This one over here?
What's it?
Yeah, do you want to tell me how we did it?
Sure. Alright, so you plus a 5.
Plus the 5? Add the 5?
4.
Add the 4?
Yeah.
Sure.
Plus a 4.
What does that give me on the other side?
9.
Yep.
Minus 7x.
Perfect. I'm happy with that so far.
Times by 3.
Okay. And what is it?
9 by 3 times 7 by 3.
Good. Okay. Just stop you right there. That's really important. When you see a fraction, you guys are really good at recognizing that it's multiplication you need to do, right? But the thing that students often make a mistake with is that when they say, I'm going to multiply by 3, what do you think they do? They multiply like the 9 by 3, but then what do they forget? They forget to multiply the 7x by 3 as well. Yeah.
Can you do like 3 and then brackets 9 take away 7x?
Yep. So let's do that, actually. So like this, you mean?
Yeah.
Yep.
Like that.
And that's probably a good reminder for you to multiply everything in there by 3, right? Keep going for me, Willem. Willem, keep going for me.
What am I up to? Minus 1.
Yep. Take away 1 from both sides.
Yep. Plus 21x.
So your battery's low.
Yeah, I'm gonna go for a quick recharge in a second. So add 21x to both sides. Yep.
Yes.
So 26x.
And divide it by 26.
And look at that. That's a really nice answer at the end. It's just 1, funnily enough, right? And the thing that I always do before we write the final answer, I check, is this actually going to work in this equation? You can actually put in this expression here into your calculator, or you can just do it in your head, right? 5 plus 1 is 6. 6 divided by 3 is 2. 2 take away 4 is negative 2. That works. And same thing here. If x is equal to 1 here, that's also equal to negative 2. Both sides here are equal to minus 2 here. Right? So you can see that does work. It's really important. The last tip for you guys can know if your answer is right or not. You can always check your solution. So you should always check and substitute these guys back in to the original. Okay?